Good morning everyone, I am Lil Christian M. Huat, and today we're going to talk about geometric sequence. By a sequence, we mean an arrangement of numbers in definite order according to some rule, and a sequence is said to be geometric if the ratio of any term to its preceding term is the same throughout. Geometric sequence is a sequence of numbers where the ratio between consecutive terms is constant, and the geometric series is a sum of a sequence. For example, we have 2, 4, 8, 16, and 32. We can notice that the next number is the result of the previous number multiplied to the common ratio. Here we have 2 times 2 is equal to 4, 4 times 2 is equal to 8, 8 times 2 is equal to 16, and 16 times 2 is equal to 32. And thus, we have the recursive formula a sub n is equal to a sub n minus 1 multiplied to the common ratio r. The recursive formula can only be used if the term before the missing term is given. For example, we have a sub 1 is equal to 1, a sub 2 is equal to 2, and a sub 3 is equal to 4. Let's find a sub 4. By substituting it in our recursive formula, we will have a sub 4 is equal to a sub 4 minus 1 multiplied to r. And a sub 4 minus 1 is equal to a sub 3 multiplied to r. Our r is equal to a sub 2 over a sub 1, which is equal to 2 over 1, simply equal to 2. Substituting it here, we have a sub 4 is equal to a sub 3 or 4 multiplied to 2. And we have a sub 4 is equal to 8. However, it will be hard for us to find any term by just using the recursive formula. That's why we have the explicit formula. We get the explicit formula because our sequence can be expressed as a sub 1 multiplied to r, a sub 1 r squared up to a sub 1 r raised to n minus 1, where a sub n is the nth term, a sub 1 as the first term, r as the common ratio, and n as the number of terms. Let's have an example. Given the sequence 64, 32, 16, 8, 4, and so on, let's find a sub 10. Substituting it in our formula, we have a sub 10 is equal to a sub 1 multiplied to r raised to 10 minus 1, which is equal to 9. A sub 10 is equal to a sub 1, and that is 64. Multiplied to r, we have r is equal to a sub 2 over a sub 1, which is equal to 32 over 64, simply equal to 1/2. Therefore, we have 64 multiplied to 1/2 raised to 9. So we have our a sub 10, which is equal to 64 over 152, and that's equal to 1/8. Now, we have the geometric mean. The geometric mean is of any two positive numbers, a and b, is given by square root of ab. For example, we have the sequence 4 blank and 64. Let's say that a is equal to 4 and b is equal to 64. In order to get the geometric mean between them, we have square root of 4 times 64, which is equal to square root of 256, which is equal to 16. Checking our answer, we will have 16 times 4 is equal to 64, and 4 times 4 is equal to 16. Moving on, let's try to find the sum of a finite geometric series. For that, we have the formula s sub n is equal to a sub 1 multiplied to 1 minus r raised to n over 1 minus r. A finite geometric series is a series containing a finite number of terms. For example, we have the series 3 plus 6 plus 12 plus 24 up to 1,536. Substituting in our formula, we have S sub n is equal to a sub 1 multiplied to 1 minus r raised to n over 1 minus r. We have a sub 10 is equal to a sub 1 multiplied to 1 minus r raised to 10 because there are 10 terms all over 1 minus r. And we have s sub 10 is equal to a sub 1, and that is 3 multiplied to 1 minus our common ratio. Our common ratio is equal to 6 over 3, simply equal to 2. Multiplied to 2 minus 2 raised to 10 over 1 minus 2. We have 3 over 1 minus 1,024 over 1 minus 2. And so we have S sub 10 is equal to 3,069. Of course, if we have a finite geometric series, we also have the formula for our infinite geometric series. Here we have S sub n is equal to a sub 1 all over 1 minus r. If you remember, we have our formula in our finite geometric series. S sub n is equal to a sub 1 multiplied to 1 minus r raised to n over 1 minus r. But here, since it is infinite, we will have r raised to n is equal to 0. And 1 minus 0 is equal to 1. And a sub 1 multiplied to 1 is simply equal to a sub 1. For example, we have to find the sum of the sequence 1, 1/3, 1, 9, 1 over 27, and so on. So we have the series 1 plus 1/3 plus 1 over 9 plus 1 over 27, and so on. We have a sub 1 is equal to 1, and r is equal to a sub 2 over a sub 1, which is equal to 1/3 over 1, simply equal to 1/3. Substituting it in our formula, we will have S sub n is equal to a sub 1 over 1 minus r, which is equal to 1 over 1 minus 1/3. And 1 minus 1/3 is equal to 2/3. And therefore 1 over 2/3 is equal to 3/2. Therefore, the sum of that infinite geometric series is 3/2. For us to fully understand more about geometric sequences and series, let us try to solve some problems. In problem number 1, we have the given a sub 3 is equal to 9/2, a sub 6 is equal to 243 over 16, and we are asked to find S sub n. For us to find our common ratio, we can actually use the y minus x root of a sub y over a sub x, where a sub y and a sub x are non-consecutive terms of in a geometric sequence. So, substituting our given, we have 6 minus 3 root of a sub 6 over a sub 3, and that is equal to the cube root of 243 over 16 all over 9/2, that is equal to the cube root of 27 over 8 equal to 3/2. So we have our common ratio 3/2. Now let's find a sub 1. We have a sub 1 is equal to a sub 3 over r squared. Our a sub 3 is 9/2 as in the given, and our r is 3/2. 3/2 squared is equal to 9 over 4. And 9 over 2 over 9 over 4 is equal to 2. Now, substituting it in our formula in finding the sum of an infinite geometric sequence, we have S of n is equal to a sub 1 over 1 minus r. S of n is equal to a sub 1, and that is equal to 2 over 1 minus common ratio r 3/2, which is equal to 2 over negative 1/2, which is equal to negative 4. So the sum of this series is negative 4. Now let's go to the second problem. I noticed that every school year my allowance triples, and during my first grade my allowance is 5 pesos. How much will be my allowance during my 7th grade? So first, let's take note of the given. We have a sub 1 is equal to 5 pesos or 5, and we have our common ratio is 3 because his allowance triples. So let's use the formula for finding the nth term of a sequence. A sub n is equal to a sub 1 multiplied to r raised to n minus 1. We have a sub 7 is equal to a sub 1 multiplied to our common ratio 3 raised to 7 minus 1 is equal to 6. We have a sub 7 is equal to 5 multiplied to 3 raised to 6, or 5 multiplied to 729. And our final answer is equal to 3,645 pesos. We will have 3,649 pesos as your allowance during your 7th grade. For our last problem, let's just find the sum of this infinite geometric series. 1 plus 3 halves plus 9 over 4 plus 27 over 8. So we have a sub 1, of course, is equal to 1. And our common ratio is equal to a sub 2 over a sub 1, which is equal to 3 halves over 1, simply equal to 3 halves. So substituting it in our formula and finding the sum of an infinite geometric series, we have S sub n is equal to a sub 1 over 1 minus r. S sub n is equal to a sub 1 or 1 over 1 minus 3 halves, which is equal to 1 over negative 1/2. And so the sum is negative 2. And lastly, before we end our discussion, let's have the review of formulas. For the recursive formula, we have a sub n is equal to a sub n minus 1 multiplied to r. The recursive formula again can only be used if the term before the missing term is given. The explicit formula, a sub n is equal to a sub 1 multiplied to r raised to n minus 1, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. Geometric mean is defined as square root of ab, where ab are two positive integers. For the sum of finite geometric series, we have S sub n is equal to a sub 1 multiplied to 1 minus r raised to n over 1 minus r. And finally, for the infinite geometric series, we have S sub n is equal to a sub 1 multiplied, all over 1 minus r. And that is all. Thank you for listening. Again, I am Little Christian M. Huat from 10 Thompson, and thank you.